So let us look at some of the derivatives of exponentials, right? S- So the derivative of the basic exponential function is d by dx of e to the power of ax, which is a into e to the power of ax, right? And suppose, and please try to remember some of the hyperbolic functions here. That is sine hx is e to the power of x minus e to the power of minus x by 2, and cos hx is e to the power of x plus e to the power of minus x by 2, right? And tan hx would be sine hx by cos hx, and which would lead to e to the power of x minus e to the power of minus x divided by e to the power of x plus e to the power of minus x. Okay. And also, please try to remember these hyperbolic functions here. Cos h square x minus sine h square x is equal to 1, and cos h of minus x will be cos hx, and sine h of minus x is minus sine h of x. Okay. Yeah. So let us start uh, some of the uh, following derivatives with respect to x. Okay. Let us solve this differentiation. Okay. Derivative. So let us put u as x square. Okay. So f of u will be 3 e to the power of u, right? So u of x is x square, right? So df by dx will be df by du and du by dx. Okay. So that would be d by du of 3 e to the power of u and d by dx of x square. So which is 6x e to the power of u, and which is nothing but 6x e to the power of x square. Okay. So let us solve this. Now f of t is t, and g of t will be cos ht. Okay, we'll apply the product rule here. So d by dt is f into g, which is cos ht d by dt of t plus t d by dt into cos ht. So here this will be differentiation of t is 1. So we get cos ht, right? And this is t. Differentiation of cos ht will be um, sine ht. So let us solve this problem. Now here let us apply the product rule by rewriting this in 2 plus e to the power of minus 2x into e to the power of minus 3x. Okay, so f of x is 2 plus e to the power of minus 2x, and g of x will be e to the power of minus 3x. Okay, now d by dx f into g. So this is 2 plus e to the power of minus 2x multiplied. This is minus minus 3 e to the power of minus 3x, right? And plus e to the power of minus 3x multiplied minus 2 e to the power of minus 2x. Okay. So finally, when you simplify this, we get the final answer as this. Okay. Power of minus x. Okay. Now let us find the derivative of this. So with respect to x, so let us apply the chain rule here. So u is cos hx. So f is 4 into u cube, right? So df by dx is d by du of 4 into u cube and d by dx of cos hx. Okay, so this is 12 u square and this is sine hx, which is equal to 12 cos h square x sine hx. So let us solve this with respect to t. Okay. Now f of t will be sine ht and g of t will be cos ht. So d by dt of f into g is cos ht and differentiation of sine ht is cos ht and sine ht and differentiation of cos ht is again sine ht. So this results cos h square t plus sine h square t. Okay. So let us look at another problem. And now this is not a product of a hyperbolic function rather than hyperbolic cosine is inside the argument of hyperbolic sine. Okay, so this is a chain rule problem, not a product rule. Okay, so let us apply the chain rule here. So u is cos hx and f is equal to sine hu. So df by dx is d by du and this is sine hu and d by dx of cos hx. So this is cos hu sine hx, which is equal to uh, sine hx, and this is cos of hyperbolic function cos h of x. Okay. And keep in mind that this is inside, I mean, cos h of x has h of x inside of its argument. So this isn't a multiplication. Now let us apply a chain rule here. So u will be root x or x to the power of half and f is tan hu. Okay, so df by dx is d by du of tan hu, okay, and d by dx of x to the power of half. So this is secant h square u. Okay, so let me, this is secant h square u, right? And this is half x to the power of minus half. So this is half x to the power of minus half secant h square u. Okay. So this is, I can write this as by 2 root x. U is root x. So this is h square, or I can write this as 1 by cos h square root x. Okay. Yeah. Now let us apply the product rule here. So f of t is t square and g of t as e to the power of t. So df by df into g, which is equal to e to the power of t d by dt of t square plus this is t square d by dt of e to the power of t, or uh, finally we can write e to the power of t into t square plus 2t. Let us solve this by applying the chain rule here. So let us consider u uh, is 1 plus e to the power of minus x, and f is a root u, or u to the power of half. So df by dx is d by du of u to the power of half, and d by dx of 1 plus e to the power of minus x, or we can write this as this is half u to the power of minus half, and this is minus e to the power of minus x, or we can write this as minus 1 by 2 u to the power of minus half e to the power of minus x, or you can write as minus 1 by root u into e to the power of x, or this can be written as minus 1 by e to the power of x into 1 plus e to the power of minus x to the power of half. Okay. So let us apply the quotient rule here. So here f of x is 1 minus sine hx, and g of x will be sine hx. So d by dx of f by g, which is equal to g, which is sine hx, and this is d by dx of 1 minus sine hx. Okay, minus 1 minus sine hx multiplied d by dx of sine hx divided by sine h square x. Okay, let us solve this problem. This is minus sine hx cos hx minus, this is 1 minus sine hx, this will be cos hx divided by sine h square x. So after simplifying it, you get minus cos hx divided by sine h square x. Okay.